Are you tired of wrestling with complex Nginx configuration files? Do you spend more time debugging authentication logic and sidecar proxies than you do building actual features? If that sounds familiar, you're in the right place. My name is Steve, and in this video I'm going to show you how to escape that configuration nightmare. We'll show you how to simplify your API authentication by replacing those complex Nginx configurations with a modern, serverless solution, Cloudflare Snippets. When building a modern application, you often end up with a collection of APIs. You start by breaking down your monolith into microservices. Each one serves a specific function, but they all belong to the same app. A common and very good practice is to put an API gateway in front of these services. This is a great first step. It unifies your APIs under a single hostname and gives you a central place to manage common concerns like rate limiting, caching, and, most importantly, authentication. Instead of building auth into every single service, you handle it at the gateway. This reduces redundant code and makes your life easier. But what happens when your company grows? Soon, you go from 2 applications to dozens, or even hundreds. Now you have multiple API gateways, and you're back to duplicating configurations, especially for authentication. This sprawl becomes a nightmare to manage. What if you could centralize authentication again? But this time, at the edge of the network, before the request even hits your infrastructure. That's where modern edge computing, using tools like Cloudflare Snippets, changes the game. By placing your authentication logic here, you create a powerful and highly efficient security perimeter. Unauthorized requests can be rejected instantly, saving your origin servers from unnecessary load and reducing your attack surface. For years, Nginx has been a go-to for many developers as an API gateway. It's powerful and fast, but let's be honest, it comes with its own set of challenges, especially when you push its configuration to the limits. First, the steep learning curve. Its syntax is complex. It's not just about proxy_pass. It's about location blocks, rewrite rules, and if statements that don't always work as you'd expect. Getting a new developer up to speed is a significant time investment. Next, the it depends configuration. The correct placement of rules isn't always obvious. Where you put the auth_request directive matters immensely. Put it in the wrong block, and it might be ignored silently, leaving you to wonder why your auth isn't working. This leads to brittle, hard-to-maintain files. Then there's the lack of modern dev tools. Debugging can be a nightmare. You can't just console.log the headers or the request body. Your best bet is often enabling verbose error logs and then trying to find your specific request among thousands of others. It's painful and slow. This leads to configuration sprawl. Even simple requirements, as we'll see in a moment, can lead to verbose and complicated config files that are hard to read, review, and get right. Finally, it's inconsistent across environments. The Nginx skills you have for a VM don't always translate perfectly to Kubernetes. The Nginx ingress controller is fantastic, but it uses a different flavor of configuration through annotations, forcing you to relearn the same concepts in a new dialect. So let's look at a typical Nginx setup for handling authentication. Imagine a request comes in with a valid session cookie. Step 1. The request hits Nginx. Step 2. Nginx sees a rule that tells it to perform authentication. It pauses the original request and sends a sub-request to an authentication proxy service. Step 3. This proxy validates the cookie, confirms the user is legitimate, and returns a "202 accepted status" back to Nginx. Step 4. Nginx sees this 202 accepted as a green light and finally forwards the original request onto the backend service. This works perfectly. But what happens if the request has an invalid session cookie, or no cookie at all? The flow starts the same. Nginx sends the request to the auth proxy. But this time, the proxy returns a "401 unauthorized status." And here is the core problem. Upon receiving that 401, Nginx is configured by default to terminate the request completely. It returns a "401 unauthorized error directly to the user. And this is what that logic looks like in an Nginx configuration file. The key directive here is auth_request. This is the instruction that tells Nginx to trigger that sub-request to the /auth2/auth location. That location block then defines where to find our authentication microservice. The entire all-or-nothing behavior hinges on the status code that comes back from this sub-request. Because Nginx's default behavior is to deny access on any error code, we get stuck. This single directive creates a rigid, binary outcome. Either the user is 100% in, or they are 100% out. This all-or-nothing approach is a major issue for applications with both private and public endpoints. Imagine an e-commerce API. Anyone should be able to browse products. That's a public endpoint. But only logged-in users should be able to add items to their cart, a private endpoint. With the previous setup, the anonymous user trying to browse products gets blocked. They get a 401 forbidden error, and your application is effectively broken for all non-logged-in users. So the requirement changes. We now want Nginx to always forward the call to the backend, regardless of the session cookie's validity. If the cookie is valid, we want Nginx to set a header, let's say X email, with the user's email. If the cookie is invalid, it should set that same header with a blank value and still pass the request along. This way, the backend service is always in control. It can check for the presence of the X email header to decide if a user is logged in and can add to their cart, or if it should just serve the public product catalog. This is definitely achievable with Nginx, but look at the configuration required. You need more location blocks, auth_request_set directives, and complex variable manipulations. We are adding even more logic into a system that was already hard to manage and debug. We're essentially programming in a configuration language, and we're working around the tool's limitations, not with its strengths. This is technical debt waiting to happen. So what's the alternative? Moving this logic to the edge with Cloudflare Snippets. Think of a snippet as a small piece of serverless JavaScript that runs on Cloudflare's global network, close to your users. This approach has huge advantages over the traditional Nginx setup. First, zero infrastructure overhead. This is a game changer. You can stop managing servers, patching Nginx, or worrying about scaling your gateways. Your team gets to focus on building features, not managing infrastructure. Second, it's globally fast, by default. Because the code runs on the edge, authentication happens in a data center physically close to your user. This dramatically reduces latency and gives every user the best possible experience, no matter where they are in the world. Third, you empower your developers. You replace rigid, complex configuration with the power and flexibility of JavaScript, a language they already know. This lowers the learning curve and makes them more productive. Fourth, you can ship faster and safer. Writing simple, readable code with modern tools like try/catch for error handling makes it far easier to review, test, and debug. This reduces the risk of misconfigurations that could lead to security loopholes. And finally, it scales on demand. Whether you have 1 user or 10 million, the serverless platform handles the load automatically. You never have to intervene manually to provision more capacity. Now let's see this in action. We can rewrite our entire authentication logic in a snippet, and as you can see, the code is explicit and readable. Let's walk through it. The function starts by grabbing the incoming cookies. It uses a regular expression to find the specific session cookie we care about. In this case, _auth_proxy. Next, it prepares to call our external authentication service. Notice the if statement. It only adds the session cookie to the validation call if that cookie was found in the user's request. Then, we get to the core logic, all wrapped in a try/catch block, which gives us fantastic error handling right out of the box. Inside the try, it makes an async fetch call to our auth microservice. This is the direct, modern replacement for Nginx's auth_request. If the validation is successful, our auth service returns the user's email in a response header. Our snippet reads that email from the XAuth request H email header. Now, here's the crucial step that solves our public versus private endpoint problem. If that user email exists, we add it to a new, clean set of headers with a clear name like May email. If the user wasn't logged in, the user email variable is empty, this if block is simply skipped, and no email header is set. Finally, the snippet creates a new, modified request containing our clean headers and forwards that to the backend. The backend service now only has to check for the presence of the May email header to know if a user is authenticated. No complex directives, no sidecar auth proxy, just a few lines of clean, testable, and debuggable JavaScript that handles both authenticated and anonymous users with elegant simplicity. Let's recap. While Nginx is a powerful tool, using it for complex authentication across many applications creates a configuration and management bottleneck. It's hard to debug, inflexible for mixed public/private endpoints, and creates a knowledge silo in your team. By replacing that complex Nginx layer with a Cloudflare snippet, you move your authentication logic to the serverless edge. You're trading opaque configuration for transparent code. You get a solution that is simpler to write and maintain, scales automatically, runs closer to your users, and empowers developers to use a language they already know. So, if you're feeling the pain of managing Nginx configurations, it might be time to simplify your authentication by moving it to the edge. Thanks for watching. If you want a deeper dive, check out the blog post linked in the description below.